Okay, so turn in your Springboard books to page 189, and we are going to look at the same lesson, lesson 15.1. There's three parts to this lesson, which is solving systems of linear equations algebraically. Just to reground us, our learning targets for this activity in page 189 is connect solutions to systems of linear equations to the points of intersection on the graph. So remember that a solution can be represented on a graph by that point of intersection, and that point is represented as an ordered pair, which has an x value and a y value. So now we're looking at solving systems of linear equations algebraically. So now within that algebraic, we can set our equations as equal, which is what we did yesterday, or we can use a method called substitution or a method called elimination. Elimination is mainly going to focus on, you're going to focus on that in Algebra 1. So today we're going to work on a method that we call substitution. So in your composition books, I want you to go ahead and glue down this notes sheet or take notes as we are going along. Remember that it's important that anything I write on here, you write in your notes. And again, ask any questions that you have. So our first step in this process is we are going to isolate one variable in one equation. So that's step one, to isolate one variable in one equation. This could be the x, or it could be the y. Could be either variable. It doesn't matter which one, whichever one you think is the easiest to isolate. So basically we want to get one solo, or we want to get one variable by itself. So here, just for the sake of doing it, I'm going to go ahead and I'm going to isolate x. So I want, if I'm isolating x, or if I'm getting x by itself, I want to move this y. So to move that y, I'm going to subtract it there. Whatever I do to one side, though, I have to do to the other. So I now have the expression x equals 8 minus y for that top expression right there. So I have isolated x by moving my y. It's the same equation, I've just changed it up a little bit. So step 2 is to substitute. That's where the name of this is. Substitute this expression into the other equation. So for my other equation, let me use some different colors here to help to show this. My other equation, I have 3x because if I'm looking at this, I can't solve for two variables at the same time. So that's just, all I did was take my second equation and I rewrote it. I have two variables. I need to work it out to one unknown for right now. So here, instead of writing x, I can write 3, and then I can substitute in the expression that is equivalent to x. So instead of writing x in that portion of the equation right there, which is what I would normally do, I'm going to go up here and I'm going to take the expression that's equivalent to x, so the other side of the equal sign, and I'm going to add that in. So I took my expression equivalent and I just put it in. Instead of writing x, I put in the expression. Now this is important to add to your note sheet. When you write it in, you should have it with parentheses. Because if you look at this right here, that looks like 38 minus y, which is very different than the expression itself. So when I look at it now, a good way to check it, or a good thought process to think to myself is, do I have one unknown? Once you have substituted it in, do you have one variable? So in that equation right there is their one variable. Y. Yep, it's the same variable. Okay, so it's the one variable, it's the same variable. Now all I have to do is solve. So my third step is to solve for this variable. So here we go. I'm going to go ahead and distribute. Let me change this pen color back to black. So I'm going to go ahead and distribute. So 3 times 8 is 24. Minus 3 times y is 3y. Plus 2y equals 14. Combine like terms. 24. Negative 3 and positive 2 is negative 1y equals 14. I'm going to go ahead and just keep going down. So here, if I want to isolate my variable, I'm going to subtract 24, subtract 24. So negative 1y equals negative 10. Divide by negative 1, divide by negative 1. Y equals 10, because my negatives cancel. So I've got my y value. Now I'm at step 4, which is to substitute that y value into one of the original equations to solve for x. I think it's important at this point to recognize that you could solve it in. I say original because if you've made a mistake in rewriting the equation, then you're about to make a mistake in both variables. But as long as you check your answer, you could solve this in for either one. So when we manipulated it, we said that x equals 8 minus y. Well, now we know that the y value is 10, so I can say x equals 8 minus 10. Sorry, that's sloppy. Let me fix that. The way I got that 10 is that y value right there. So 8 take away 10, so x would be negative 2. So according to that, my solution is negative 2, 10. Because my y value is 10, my x value is negative 2. My fifth step is to express the answer as a coordinate or an ordered pair, which is always x comma y. So here it says check your solution using the other equation. Now this is so crucial, and I think you actually have to write this in your notes. I think that it's cut off, so make sure that you write this. So if I go back up, the equation that I'm talking about when I say the other equation is I solved for x using this first equation. So I'm going to check my answer using the second equation. So my second equation is 3x plus 2y equals 14. Just make sure I'm right in that. Yep. Okay, so I've got 3, and I'm checking it using substitution. So 3 times negative 2 plus 2 times my y value is 10 equals, let's see, 3 times negative 2 is negative 6 plus 2 times 10 is 20. 20 plus negative 6 is 14. It checks. Okay. Great. So right now I want you to pause and I want you to turn and talk and explain the steps of this process. What did we do each time? And then we're going to do 2 more examples together. But for right now, you're pausing and you're summarizing with a partner. Take turns explaining what happened at each step of the process. Great. So let's jump from our notes and let's go back into page 191 under the Try These B, and we're going to do 2 more examples together. So our first example, we should take a look, and we're going to go back and forth between our steps. So the first step is to isolate one variable in one equation. If I look at this first equation right here, I notice that I already have a variable isolated. So I don't have to do anything in my first step. It's already done. My second step is to substitute this in. So I have this expression for y, and I'm going to take my equation x plus y equals negative 6, and I'm going to take out the y but I'm going to substitute in the value that it gave me for y. So here, for that value, I'm going to say x plus 5x equals negative 6. So all I did was substitute out my y and put in the expression that is the same value as y. So x plus 5x would give me 6x, which equals negative 6. If I divide out my 6, divide out my 6, x equals negative 1. From here, if I know that x equals negative 1, if I go back to my steps, substitute with that, did that, solve for the variable, substitute into one of the original equations to solve for the other variable. So now I'm going to go back up and I'm going to substitute this value in for x. So y equals 5 times x. So in other words, y equals 5 times negative 1. So much going on over here. So y equals negative 5. So my next step, I substituted. I'm going to express my answer as an ordered pair, and then I'm going to check it using the other equation. So my ordered pair right now, my x value is negative 1. My y value is negative 5. So I'm going to check that using the second equation. Just change colors here real quick. My second equation is, just pull it over right here, x plus y equals negative 6. I just pulled that. That's my second equation. Now I'm going to take my value for x, which is negative 1, plus my value for y, which is negative 5, and that equals negative 6. It checks. At that point, I'm going to make sure I circle my answer because I've got a lot of work going on, and that helps me organize it and be able to find it. Okay, now there's a couple ways to do letter B. I'm going to go ahead and erase my screen to make some room for letter B. The way that I'm going to show you is only one of several ways to solve this problem. If you have a different preference, it's absolutely fine. You can solve it using a different preference. So if I look back at my steps, step 1, isolate one variable in one equation. So up here, the variable that I'm going to isolate is I'm going to isolate x. It doesn't have a coefficient with it. It's already by itself, so I'm going to isolate x. So I'm just going to go ahead and rewrite this to kind of show how I'm isolating x. Don't want that pen. I do want to write in black. All right. So I want to get my x by itself, then I want to get rid of whatever's with it. So I'm going to subtract the 2y. Whatever I do on one side of the equation, I have to do on the other. They're not common. They're not common terms, so I can't just do 6y. So over here, I'm left with x equals 8 minus 2y. So I know that. So now I'm going to go down to my second equation, and I'm going to substitute that in for x. So I have 3 times x, that right there is my x, minus 4y equals 4. So there's my x, and I'm going to take this expression that is equivalent or equal to x, and I'm going to substitute it in right there. 8 minus 2y. And again, I'm going to put parentheses around it. Okay, so now from here, I can go ahead. I have one variable that I'm looking at. So I'm going to go ahead and I'm going to solve. I'm going to solve for y. So I distribute. Is this the same one that we did over here? No, a little bit different. Just making sure. They looked familiar. So I've got 3 times 8, which is 24, minus 3 times 2, which is 6y. Then I bring down the rest, minus 4y equals 4. Okay, I'm going to go ahead and extend my page. So negative 6y and negative 4y, this is negative 10y equals 4. I'm going to bring down this 24. Now I'm going to isolate my variable, isolate my y. I'm going to subtract 24, subtract 24. So I've got a negative 10y equals negative 20. Divide by negative 10 because I want to get rid of the negative and the 10. Divide by negative 10. My negatives cancel. Y equals 20 divided by 10 is 2. So y equals 2. So I can go back up here and I can go to this equation. So I go back into that equation and I can say x equals 8 minus 2. And if y equals 2, instead of writing y, I would write 2. So 2 times 2 is 4. 8 minus 4 is 4. So x equals 4. So now if I'm going back and I'm checking my steps, did I substitute? Did I have one variable? Yep. Did I solve it? Yep. Did I substitute it in and solve it? Yep. So I'm on step 5. Express the answer as an ordered pair. So my answer is an ordered pair. Remember, an ordered pair is always x comma y. So my answer to an ordered pair would be 4 comma 2. And I'm going to check my answer using the other equation. So I'm going to go to this equation right here, the one that I didn't use to write it up there. And I'm going to substitute it in. And I'm kind of out of space, so I'm just going to keep moving over. You have a lot of space in the margin of your book. You can keep going down. So we have 3 times 4, because that's my value for x, minus 4 times 2, and that should equal 4. Let's check it out. 3 times 4 is 12. 4 times 2 is 8. 12 minus 8 does equal 4. It checks. It works. So once I've checked it and I've checked my answer, I'm going to go ahead and circle it. Again, any questions that you have, I want you to write them off to the side and we'll talk about them. Okay, so now we're on the worksheet. This is your worksheet. It's actually the worksheet from yesterday. It's the bottom half. We're now on the bottom half. So we are going to work on solving systems of equations by substitution. And you can ignore where it says version 2. I kind of changed the versions because version 1, version 2 is different. So they're technically both substitution, but I gave them different names. So I want to take a look at number 1 together. Let's not forget what we did yesterday. So you notice here that both variables are isolated. You can use either steps, but for this substitution method, you only have to isolate one variable. So the easier method here is to set them as equal, to set it as a y equals a y, because you have the same variable isolated. So you could just do 2x plus 3 equals 5x. Then you can go ahead and solve for x. You subtract 2x from both sides. You get 3 equals 3x. Therefore, x equals 1. Then you can go ahead and substitute that in. Y equals 5. I'm looking at the second equation, times 1. So y equals 5. My ordered pair would then be 1, 5. Let me check that up here using the first one. 2 times 1 is 2, plus 3 is 5. It checks, and I'm going to circle it. So don't forget that that works when you see two variables isolated. But now if we look over at number 2, we only have one variable isolated. So therefore, we would use that substitution method that we just learned today. So here, if I take my first equation that doesn't have anything isolated, that's how I know to take that equation. I have 4x plus 2y equals 16. Now instead of writing my y, I'm going to take the expression that's equivalent to y, which would be, and put parentheses around it, 2x plus 4. From there, I can go ahead and solve everything. So I can solve for x, and then I can substitute it in, solve for y, and check it. So here's the rest of your worksheet. This has a variable isolated. Once you get into 4, 5, and 6, you need to isolate the variable. So the first isolate variable. So the first couple have a variable isolated for you, but then 4, 5, and 6, you need to pick a variable and you need to isolate it. If you are finished earlier, if you are a quick worker, then you can check your answers in Schoology. It'll be titled Substitution. Okay, it's not graded, it's just for practice, but you can check your answers in Schoology. If you didn't get as far as you wanted yesterday, you can go back and you can work on setting them as equal. We are going to catch up on both of these two topics tomorrow. Again, write down any questions that you have.